Okay, this is grade 11 pre-cal. This is lesson 8, talking about the unit circle. So this first page is about the math, and what I'm going to do is we're eventually trying to get to this. This is the whole circle here. So we're going from 0 to 360, and we're going to figure out what all these x and y coordinates are. So let's go back to the first page here. So a couple things let's deal with. We got x is cosine, y is sine. Easy way to remember this, alphabetically, x comes before y, cosine comes before sine. Easy way to remember it. Tangent is just the y over the x. So what we have is the kind of the two angles here that we're going to deal with, 45 and 30. We'll come back to that in a sec. Let's go to the unit circle on the next page, second page here. So we'll label this. So we start here at 0, then we label our 90, our 180, our 270, and our 360. That's a good place to start. Now, a unit circle means that the radius of this case is 1. So from the center, the origin to this outside piece is 1. So the x value is 1, and then our y value is 0. If we go 90 degrees, it's 0, 1, because we don't go left to right x, we go up on the y. 180 is negative 1, 0. Down here at 270, we have 0 and negative 1. So that's the first set of lines you put in. Then we're going to deal with the 45s. So we draw on our 45s, our 135, our 225, and our 315. Now, if you look, both the x and the y coordinate are root of 2 over 2. You really don't have to know where we got that from, but I'll show you on the first page. But that is our x coordinate, so that's our cosine, and our root of 2 over here. The second one is our y value. And if you actually did tangent, which is y over x, you'd see that it's that divided by that, which is 1. And so the tangent of 45 is 1. So go back to the first page here. You can see how we do this. Now, the outside hypotenuse is, remember, it's a unit circle, so it has a radius of 1. It's an isosceles triangle because both side lengths are the same. They're both 45s, so we can just do Pythagorean theorem. We end up with 1 over root of 2. But back in the previous grade, we learned that you can't leave a radical on the bottom. We can't leave root of 2 on the bottom. So we times both the top and the bottom by root of 2, and we end up with root of 2 over 2. So 1 over root of 2 and root of 2 over 2 are exact same thing. The one we're going to use is this one here, the root of 2 over 2. So you can see, yeah, there's our root of 2 over 2 and our root of 2 over 2. Now we go to quadrant 2. The only difference is the numbers are the same, but now our x coordinate, our cosine, is negative because we're in quadrant 2, right? It's negative over here. We go down to over here. Both are negative, both cosine and sine are negative. And then we go back to quadrant 4. The y is the negative. Okay, so that's the 45s. Now, the next set of lines, you're going to put in are the 30s and 60s. Now, you're thinking, oh, I'll just cut 45 in half. No, that would be 22 and a half. So 30 is just under 45 and 60 is just over 45. So you can draw these lines in here and lines here. Now, if you look, 30 and 60 are really similar. They use root of 3 over 2 and a half and root of 3 over 2. Those are the only numbers you're going to use for 30s and 60s all the way around here. So let's show how we got that. Go back to the first page here. We break it down into our 30, 60, 90 triangle. We need this extra side here. So based on Pythagorean theorem, right, we have a long side, we have a short side. Well, we square 2 is 4. We square 1, which is 1. 4 subtract 1 is 3. Take the square root of it, root of 3. Now, how do you get sine and cosine? Well, that's easy. Look at this 30 here. Sine is opposite, which is 1 over hypotenuse, so a half. Cosine is adjacent over hypotenuse, root of 3 over 2. Yeah, and you can see where we generate those from. So now when you're dealing with the unit circle, it's sometimes people forget which ones do they put in first. So it's interesting. Look at this example here. If I drew a line here, and I drew myself a right angle triangle, right? You can see that's 30 degrees. You can see that the x here is way larger than the y. So that's why my x value has to be the bigger of the two values, and that's the root of 3 over 2, right? And then that, yeah, root of 3 over 2, and then the y value is a half. Now look at the 60. If you look at the 60 here, we draw a little right triangle here. We can see in this case that the y value is quite a bit larger than the x value. So my y value has to be the root of 3 over 2, and the x has to be a half. It's an easy way to remember it as you go around. Now, the only difference is when you go into the different quadrants, you have negatives for the x in quadrant 2. You can see them there. You have both negatives for the x and y's in quadrant 3, and you have negatives for the y's in quadrant 4. So this unit circle is something you're going to be using the rest of this chapter. And you'll see we'll be able to ask you. So for instance, if I could ask you, hey, what's the cosine of 330 degrees? And you would tell me root of 3 over 2. Or I would ask you, what's the sine of 150 degrees? And I would tell you a half, right? That's where it comes from. Okay, so that is the first part of the unit circle. So now we'll go on to the second part here. So let me minimize this right away. Get rid of this. And I want this one here. Okay, here we go. So now the second part of this is part 2. So we're going to talk about the unit circle. So a couple things about the unit circle. The radius is always 1 in here. X values correspond to the the X values correspond to the cosine. We already talked about that, right? I need my highlighter again. Y values correspond to the sine. Y over X gives our tangent. Now, so what we got here is we got something called all soup turns cold. And it's just an easy way to remember which quadrants things are positive in. So all soup turns cold. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So the A in this case means all of them are positive, all trig ratios, cosine, sine, and tangent. Sine is positive in quadrant 2. That's the only one. So that means cosine and tangent are negative. Quadrant 3, the only one that's positive is tangent. Sine and cosine are both negative, and we know for tangent, which is y over x, a negative divided by a negative is a positive. So tangent's the only one positive in quadrant 3. And in 4, cosine is the only one that's positive. So this is just a quick way to remind you of which ones are positive, and if they're not positive, then they're negative. Okay, so now, what we got is an example number 1. It tells us that 2 over 5 is the x, and y is the y point. It's on a unit circle, and it's in quadrant 1. And what we want to know is we want to know what the y value is. So the easy way is to draw a picture. So I draw my circle here. I draw my line somewhere in quadrant 1. My x value is 2 over 5, and my y value, I don't have a clue. But if you look, why did I put a 1 here? Well, because it's a unit circle, so the radius has to be 1. So the x value is 2 over 5. So I draw my 2 over 5 there. I have my y value of 1. I'm trying to find x. Sorry, let me phrase that. I'm trying to find y. I have x, I have the radius. I'm trying to find y. So we just use Pythagorean Theorem. You can use any values you want. I used h, x, and y. You could use r, x, and y. Radius and x and y doesn't make any difference. So what we do is we just go through Pythagorean Theorem, and we find out that it's the root of 21, right, over root of 25, right? And we know the root of 25 is 5. Okay, so that's interesting. So the y value in this case, this y value here is root of 21 over 5. Now, we know the y value could be positive, the y value could be negative, but this one specifically tells us it's in quadrant 1. So we have to make sure our y value is positive. If it said it was in quadrant 4, then all we would do is put a negative in front of this to show that it's negative for that one. Okay. Example number 2, we need to know some terminology. In this case, we have coterminal, right? And here's the initial stuff. So we draw our x and y coordinates. Where we start at is called the initial arm. Where we stop at is called the terminal arm. So in this case, bang, we stop here, terminal arm. Coterminal shares the terminal arm with somebody else. So if you think about this, let's make this line a little smaller. So if we start here and go all the way around, right? Bang, and end up here, we ended up back at our 30 degrees. Well, that is a coterminal angle, that big yellow line. So to find that, it's 30 plus 360, which is once around, so 390. So 30 degrees and 390 degrees are coterminal angles because they terminate in the same spot. And they actually match up with our interval, which is between 0 and 720, right? So if we go around this way, which is counterclockwise, it's positive. Sometimes you're going to get ones that go negative. They'll say negative to go around this way, but you always still give your coterminal angle as a positive angle. Okay, so that is the end of lesson 8. Then you can do the questions that go with that one.